So I'll begin with a couple of ICE in-class examples. I need to remind you guys about equations of lines, all right? So here's the first one. I want you guys to write the equation of a line. This is in-class example 2.1.1, which is on page 49. We skipped over it. Now I'll come back to it. Write the equation of a line containing the point minus 3, 8 with slope 3. Let's see here. What did I say? The slope was 3. Containing minus 3, 8. All right. And the second one, I want you to find the equation of the line from a comma f of a to b comma f of b. It's the very start of the limits chapter. Okay, so, all right. So you guys have any ideas? How do you find what's the equation of a line? So when I think about the equation of a line, I know a couple different things. I can use y equals mx plus b, right? This is slope. This is y-intercept. That's one thing I could do, right? Or I can use the 2-point formula. This is the line through. It's a so-called 2-point formula for a line. And then the third flavor option is point slope. So point slope looks like this. The point slope formula. The point is x1, y1. The slope, of course, is m. So the way I see it, those are 3 things that you should know from like prerequisite study of lines. So now that I've reminded you, what should we use to solve ICE 211? The first one? Okay, so I mean, y is equal to 3x plus b, then what? Then you plug in the values. So then 8 is 3 times minus 3 plus b. So b is equal to 8 plus 9. Y is equal to 3x plus 17, right? Now that's not wrong, but it's also not right in the sense that there is an easier, lazier way. The lazier way is to use point slope. See, because with point slope, you could just write it down like this. Y is equal to y1, 8 plus 3 times x minus a minus 3. This is point slope. See, if I know point slope, I don't even have to do this algebra business. I just go straight to the answer. I would strongly urge you, use point slope in this course. Don't go back to point, like slope intercept, not as efficient. Now, a lot of people like to leave their answer in so-called slope intercept form, you know? So if we work this out, what do we got? 3 times 3, right? So of course, it's the same, right? Same answer, but we arrived at it a rather different way. See the difference? Now, the 2-point formula for the line definitely is not the right choice for ICE 211 because we don't have 2 points, right? But the 2-point formula for the line is definitely the right choice for 2.12 because I give you 2 points, right? So you just think about this as being like x1, y1, and think about this as being your x2, y2. Plug it in. Y is equal to f of a plus f of b minus f of a divided by b minus a times x minus a. And there you go. This right here, by the way, guys, is the equation of the secant line. All right. So just I want to do a quick review because this lab we're doing today, it does touch on equations of lines. So for best results, you want to know, you know, these two things are helpful. I don't actually know if the main point of example 2.12 is so that it explains what's on the next page in the notes. Because like on the next page in the notes, I have the secant line demonstration. So like basically this in-class example derives the formulas for the picture on page 51. All right, let me go on here. So let me remind you, if we have a graph, right, and we look at this point A, right, and look at this other point over here, say A plus H, right? Then we can imagine the tangent line, right, like this, right? And the slope of that tangent line will be the limit as h goes to 0 of what? Well, let's look at this triangle right here, right? This is h. What's the change in y here? You could say h is the change in x, you know? The change in y, this symbol means change, guys. See that? Change. It means change. It's not a letter, it's just an upside down triangle. Anyway, so that little right triangle, look at it, right? So this point, the point of tangency is a comma f of a, right? What's the point up here? It's a plus h comma f of a plus h. I need stilts. I'm going to get like a platform to teach on in here, I'll tell you what. All right, so how far is that? You're going from f of a up to f of a plus h. So the distance in the y is just f of a plus h minus f of a, right? And so what's the slope of the tangent line? It's the rise over the run, right? The rise here is given by f of a plus h minus f of a, and the run is just h. Slope of the tangent line. So we also, last class, we said that we're going to call that, when it exists, f prime of a. Right? It's the derivative of the function at a. That is the slope of the tangent line to the function at a. I wanted to draw this little picture for you to try to explain to you where that formula is coming from. I didn't draw the picture last time. Right? What's the equation of the tangent line? Well, the equation of the tangent line by point slope is f of a plus m times x minus a, right? But this m we can write as f prime of a, right? So this equation of the tangent line right there by point slope. Now, there is another way to calculate the derivative. The other way that we sometimes use is this. Limit as x goes to a of f of x minus f of a over x minus a. I just want to warn you, sometimes the h formulation is easier, sometimes the x approaches a formulation is easier. It just kind of depends on the problem. To get from here to here, you make a substitution. The substitution is just this. X is equal to a plus h. That's just a substitution. So if you look at it, if h goes to 0, a plus h goes to a, right? So you can see that you can trade this limit for that limit if you want. So in this lab, I ask you to take a picture of a couple calculations on the board. Let's do those before the lab starts, okay? So let me tell you what, I'm going to do one of them. Well, let's see how it goes. Where'd it go? Trying to find my way back to your lab. So you guys should open up the lab if you haven't already. Do you know where it is? Go to course content, go to labs and lab materials, I think. There's a folder. The only thing in that folder is lab 1. It has a Word document in there. And the way this is going to work is pretty simple. Basically, you just take the Word document that I give you, and then you add answers to it. You add answers to, like, there's a Word document in course content. You're going to open that up in Microsoft Word, and you're going to answer the questions on that, and then you're going to save it, and yeah. Okay, so let me do the part on the board here before I.
So we print it out?
No, there's no printing. No. We just work on it here. And then you work on it electronically, save it like on the desktop. I would email it to yourself just to be safe. Definitely email it to yourself. That's a good idea. Just in case something. Yeah, when you're done. Yeah, or either when you're done, or if you're especially cautious when you've reached significant progress. If you're like me, I had an event where I lost 3 weeks of work from my computer glitching over last Christmas break. So I'm kind of, that's not going to happen here. But anyway. All right, so one of the calculations is f of x so basically this lab, what we're going to do is I'm going to introduce you to some computer software that is helpful for graphing in math, all right? And we're going to actually calculate some of these limits sort of numerically. Actually, there's a few different things we're going to do, but let me start out with here. This is for I have f of x square root of x plus 8, a equals to 1. I'm supposed to calculate. Yep.
You want us to take notes on this?
It would be good. I mean, you can if you want to. But I want you to take a picture of it with your cell phone and put it in there. If you can do that. Well, yeah, I mean, all right, let me get to work here. So f of x is square root of x plus 8. A is equal to 1. And I just want to work out what's f prime of 1. So what do you guys want to use let's use the h formulation, right? Limit as h goes to 0 of f of a plus h. But here a is what? A is 1, right? So I do f of 1 plus h minus f of 1 divided by h, right? How's that work? So that's the square root of 9 plus h minus the square root of 9, which is 3, right? I made a couple steps there in my brain. Did you guys follow me? Do you want me to write it? Let me write it out.
Yeah.
Write it out. Sorry. 1 plus h plus 8 minus the square root of 1 plus 8, which simplifies to the square root of 9 plus h minus 3. Or you could write the square root of 9 if you like, whatever. I'll write 3. Now, what kind of limit are we looking at? So I told you guys last class, every one of these derivatives, it's going to be indeterminate type 0 over 0 when you start it. So the way to solve this kind of one is by this following trick. What you want to do is kind of like multiply by the same pattern, but with a plus. Right? What happens when you do that? Well, some pretty cool stuff. So we get 9 plus h minus 9 divided by h times the square root of 9 plus h plus 3. I haven't written the cross terms because the product of 3 in the square root and minus 3 in the square root, they're equal and opposite and they cancel. That's the beauty of multiplying by the blue factor here. And notice the 9's cancel, right? See that? Those 9's cancel. And then the h's reduce. See this? And then this guy and that guy cancel out. And we're left with the limit as h goes to 0 of 1 over the square root of 9 plus h plus 3. Which is what? Now we can just plug it in, right? This is a continuous expression at 0. We can just plug it in. We get 1 over the square root of 9 plus 0 plus 3, also known as 1 over 3 plus 3, also known as 1/6. All right, so this is how we can work out this derivative by hand. All right? So that's like A. And then B is f of x equal to sine of x. I'll work that out tomorrow. We'll learn that f prime of a would be cosine of a. It takes me a little while to derive that, though. Okay? C, the other example we're looking at in the lab, is f of x equals to the absolute value of x. All right? And we're going to look at a equals to 0. so let's see how this goes. F prime of A, limit h goes to 0 of, f of A. Well, let me just write it as absolute value. Absolute value of A minus absolute value of 0 divided by h. Of course, that simplifies to just the limit as h goes to 0 of absolute value of, oh, good grief. I'm an idiot. I'm so sorry. Dummy. I'm supposed to do f of a plus h, right? Which is what? 0 plus h here? What is that? Absolute value. See, this is what I get for not writing steps down. So should this be absolute value of a? No, that's supposed to be h, right? Which is far more interesting, see, because now we have absolute value of h divided by h. What happens to absolute value of h as h goes to 0? Well, it goes to 0, right? What happens to h as h goes to 0? Well, h goes to 0. So this is type 0 over 0. Now, check this out. Limit as h goes to 0 from the right of absolute value of h over h. What's that? Excuse me. 1, right? How about if we look at values to the left of 0? Well, then, how does absolute value work? Then h would be negative, right? So the absolute value of h would be minus h. So what happens here? Oops. We have the right limit is 1. We have the left limit is minus 1. What does this say about the derivative at 0? F prime of 0 does not exist. Right? And I would point out, you can understand this one kind of like graphically. It's pretty easy. Looks like this, right? This is y equals absolute value of x. So like the slope of absolute value of x, it's 1 to the right of 0, right? But the slope of the absolute value of x is minus 1 to the left. I'm just advocating a new idea that we can talk about the slope of a function as being defined by the derivative of the function at a point, right? So that's it, all right? That's all I got to write on the board here today. And now we can... D and E. Oh, does not exist. Does not exist. And whenever we write does not exist, it's almost always does not exist as a real number. I mean, if you want to be kind of like a jerk about it and like a philosophy major, you'd be like, well, we're having a conversation about this thing, and it exists in some sort of sense, you know? If it didn't have some kind of existence, we couldn't very well talk about it not working out. But anyway, the point is, the derivative at 0 does not exist here because, and so this is like one of the things, if we're looking at a function and you're trying to decide is it differentiable or not, if there's a kink or a corner in the graph, it won't be differentiable at such a point because like the left and the right tangents in some sense won't match up. So, all right, so let's get started on the lab, guys. Let me try to walk you through it. I will try not to be, like, you guys can work at your own pace. It is a lab, but I want to make sure we're all on the same page for some stuff. Like, to start with the Desmos, have you guys ever used Desmos before? There's a link. So look at the word. See that? Desmos.com. Or you can just type it into the web browser. Use Chrome. I would advise using Chrome.
I have to download it here.
Yeah, if you need to update Chrome or whatever, go ahead and do that. That'll happen sometimes. So let me talk you through the different parts of the lab. So to start with, you're going to open up Desmos. You're going to get started in there. Like the next move is to graph 3 functions in Desmos and take screenshots of those. Do you guys know how to take a screenshot on the computer? It's like the window key and Shift S or something.
On my computer, there's a little app for it. Where you can screenshot the whole computer.
Yeah, I think in like these Windows machines, if you do the Windows key, Shift and S, it will allow you to, like, try it out. Windows Shift S. It'll make the screen kind of like gray, and then you can drag a box and snip whatever you want. And now it's in the clipboard. Once you do that. Now you can take the screenshot however you're comfortable. I'm not saying you have to do it the way I did it by any means. I learned that from a student last year.
I get help. Yeah. Click on this link.
No. Oh, wait a minute. So, I'll write it on the board. It's this key. All 3 of those keys at once. It makes the screen go gray, and then you can drag a window and snip it. Once you do that, when you go back into the Word, you should be able to paste that picture in because it's on the clipboard. I used to always do control print screen, like that's how mine does it, my computer. Control print screen, that's the way I do it, but I know on Mac, you're saying on the Mac, there's an app or something.
No, that's Windows.
That's Windows. Oh, you got different.
Here, snipping tool.
Yeah, seriously, however you guys want to do it, it's all good.
Getting to Desmos.
Tell you what, I'm going to work over there. Do-do-do-do. Although, of course, videoing this is really stupid because it's going to be all, rainbow bandy, so, oh well. I'm trying to keep my distance from you guys because I'm sick and I don't know, it's probably cold, but me keep my distance. So like I'm not planning to come to school tomorrow. I have a very good video of the next part of the material, like the derivative of sine and cosine. I lectured that last year. I rewatched the lecture again like this morning. It's good. So it's exactly where we are. So it won't waste your time. So I'll send you a link to that. Once I.
Yeah, and that's tomorrow's lesson.
So tomorrow's lesson will be video. And I'm sorry I won't be here, but I'm trying to, get better. I would have stayed home and just asked you guys to do this by yourself, but I don't think it works. Like I can't communicate this stuff except in person, and there's really nobody else who can, walk you through. So did you guys open Desmos? Did you get the?
It didn't work.
It didn't work.
Did you pick Chrome, Firefox, or Microsoft?
So I use Chrome, and I will say, the first time I used it, I think it said something like you're talking about, but then I just tried it again, and it worked. So just go to the address bar and go like www.desmos.com and see what happens. So can you guys get to here? Let me turn off the lights so you can see better. Could you get to here? Well, she got to there. Okay. There you go. Now try clicking on the graphing calculator. Let's see what happens there.
Yeah, I got it.
All right, so now you guys, you want to start an account so you can save things, yeah? So I think sign up. Yeah, hit the sign up, and it's free. Use whatever you want, but like, so you can save your work in there, and you can title it. You can share it with friends. You can even edit. You can edit a graph, more than one person at the same time. Do all kinds of stuff in here. Now, what did I say? Well, you guys let me know when you're signed up. Are you signed up? You good?
Yeah.
All right. So I asked you guys to graph. Oh, let me. Okay. I'm opening up your lab. So you can. It's very simple. Just try like putting in y equals whatever it said in there. I haven't memorized my lab. Otherwise, I'd tell you. Goodness. So sin x. Did you guys graph it? So all you do is like y equals sin x in that, see that? You put it up here, just like click there and write y equals sin x, and there you go. Pretty simple, right?
Yeah.
Now I think I said to take a picture of that, so how you can do that? You could either use the screenshot tool, or you could also save it from here. See, if I click on this button, share graph, export image, I can like download a PNG. But I don't know,
To out your account.
to my account?
Does it save on your account when you...
Oh no, it just, the file, it shows up on the computer. See, like here? See, it opens up Paint. Now, of course, I think the fastest way to do it, guys, is just to do a screenshot here, right? Like Control Shift S Z, and then I can snip it. I think I snipped it. And then I go back over here, and I hit Enter, and I paste. And I tried to paste, and apparently I didn't copy it. Try it again. See, guys? Behold. Something like this is what I want you to do. I just want you to paste the picture in there. Because in all these labs we're going to be doing, you want to be able to make a picture and then put it into your documentation, right? So, got to figure out a way to do that. It doesn't have to be that big. You can make it tiny if you want. I don't care. You can cut and paste from the Word document into the Desmos, but it's kind of dangerous. Sometimes there's like hidden character stuff in the Microsoft Word that when you cut and paste into the Desmos, it doesn't like it. So, like, I usually just retype it, you know? Like, for the next one, I'm just going to go to sign and add a caret -1. That's the inverse sign.
When you snip the picture, where will it appear?
If you go back to the Microsoft Word where you want to put the answer,
Yeah.
you can paste it. It should be in the clipboard. So that's nice, right? Because you don't have to put it somewhere officially. You just put it on the clipboard for a second and then paste. You can either keep source formatting or I don't know. There it is. Oh.
Yeah, I made it work.
Okay. So let's get these done with. Let me go on to the next part. Isn't this fun? Oh, ooh, look at that. Oops, I don't know what I did. That's something, isn't it? Y equals sine of 1 over x. It's quite different, isn't it? Oh. Oh. So are you guys on to number 3 now?
Is this right? It's very weird.
So next we want to graph, like I said, graph y equals x squared plus 3x minus 4, and also graph x e to the x equals to y. Right? I think you'll find the syntax of the Desmos very easy, right? Just click there and add another one. Even I can figure it out. Now I said to find the solution, right? Of x squared plus 3x minus 4 equals to x e to the x. So what would that be graphically? If you want to solve one function equal to another, you look for where the graphs intersect, right? So what we got to do is look for the point of intersection to answer the question. Can you see where it is? Yeah, it's close to negative. Now I said what? Get it to within what? Point. What did I say on the lab? I said find the solution with an error of no more than 0.001. So we got to do what? We got to zoom in to that point, right? So what you want to do is drag the intersection point to like the center of your screen, and then hit the plus in the upper right-hand corner. And then hit it again. Make sure you keep the crossing point. And just kind of zoom in on there. And I think if you put your I'm sick. This will be sufficient. So I get, see this? If you hover over the intersection point, it tells you the coordinates there. Now you could keep zooming in more to get more numbers, I think.
I think you can put y equals y. You will get this.
Oh, well, yeah, I'm trying not to do that. Fair enough. I mean, but, so minus 3.985 is approximately the solution, right? So the way I would document that would be to hover my mouse like that, and then take a screenshot, I guess. Although I think if you save the, if you export the image, it might put the coordinates on there. You can play with that. Oh, see, it's gone. Oh, well. Anyway. Well, yeah, if you want to make sure you've documented that that's where the solution is, you somehow have to include those numbers on the edge so you can see what the meaning of the vertical lines are, like you're saying. Anyway. Very good. So I think about minus 3.985, and so you just want to like basically type a sentence in there. So like just the solution is approximately x equal to minus minus 3.985. Right? As you can see in the picture below. And then you can cut and paste your picture in there, All right. That brings us to part 4. Notice that there's a link in the lab. You need to click on that. I think you have to go Control and click to follow the link. See that? Hit the Control button and then click it. It will take you to here. So I just made a little calculator. Oh. Is yours like that too? Oh. Um, it should have opened it up as like, what happens when you click on that? Does it open it?
You got me here.
When you click on it, does anything else happen?
I'm not sure how long it will take to update.
All right, let me try something. I will just make an announcement in Blackboard, see if this works. All right, try clicking on that, see if that works better.
No, the same.
All right, well, what's that? Yours works?
Oh,
I clicked the link on Blackboard and I talked to Blackboard.
I had it open on it. All right, it worked.
Okay. So, keep that open in a slightly smaller window so you can also look at the Word document at the same time. You want to have both side by side so you don't go crazy. All right. And so we're looking at f of x for part A, right? We're looking at f of x equals to the square root of x plus 8, right? So the first order of business is to change the formula for f of x. See that? You want to change that to what? Square root, which you can just write square root if you like. It'll come up with the root. Well, if you just do like SQRT, it'll bring a square root up. All right. Now, what was A? A was 1, right? So we already have A set on 1. And what is H supposed to be?
0.
Yeah, well, we have choices, right? 0. 0 gives us undefined, right? Which makes sense, right? When we actually plug in 0, it's undefined. So the way this works, guys, is the H slider. You can move that to the right and to left to select the values, and then you can just type those into the Word document. I would suggest, like Alf, here, minus point what? Minus 0.06. We got what? 0.1669. You can just keep 4 decimals, that's enough. Plug in minus 4, what do we get? Zero point 166. Oh, I guess I should keep 5 decimals for this one. My bad. Hard to see the difference otherwise. 0.1669. I guess I'll keep 6 decimals, 945. I guess I just kept 7. I don't know. Keep as many decimals as you want, but preferably more than 4. So I like these little sliders. You know, it's nice if you have the same formula and you want to test different values of it. It's a pretty fast way to like find numbers, don't you think? Of course, we could also use Excel. We'll use Excel next time to do some calculations. If you took one of the other sections of Calculus 1, I think they use GeoGebra in there. But I personally think Desmos is simpler, so I'm not using GeoGebra, because if the point is to solve math problems and not make the tool complicated, I think this is the way to go. Because Desmos is very, very user-friendly. So you guys got it? So next, change the f of x to sine x. Fill out the next table. Make sure you change a to 0, right? Because I said a equals to 0 for sine x. What happens when we plug in 0? It tells us, no, you can't do that. You can't divide by 0, undefined, right? That's why we need a limiting process, right? That gets close to 0, but not 0 itself. See, if you don't know about algebra, like we know about, pretty much this kind of numerical method is how you'd have to calculate the slope of a tangent line, you know? I am very glad that we can actually solve the problem of slope of the tangent line with algebraic methods in this semester for the most part. Like there's just a formula. We don't actually have to crunch numbers, you know? Except in this lab because, well, it's a lab. Hey, stop that. So as you can see, for the sine one, we've got values, what, really, really close to 1, right? That's because the derivative of sine is cosine, and cosine of 0 is 1. So, Yep, absolute value. This one's going to be very boring, right? All the negative ones are -1, -1, -1. 0 is undefined. And all the positive ones, it's always 1. 1, 1, 1, 1, 1, 1, 1, right? See that? This one's even easier. Play around with it for a second. You'll see what I'm talking about. So next up, you guys got to take a picture of what's on the board, right? Do you need me to turn the lights back on, or did you already do it?
We're good.
You already got what's on the board?